Hello and welcome back. My name is Sarah Fuentes, math specialist and instructional coach in New York City. And today's lesson will be on multiplying with polynomials, what happens when you repeatedly multiply variables together. And this is based on an earlier video I did this week with multiplying polynomials with an array model. And I noticed while I was in a classroom this week that there was some struggle on how to actually multiply the terms together. So we're going to focus on that today. But before we do that, I want to just go backwards a little bit and think about what it means to multiply different terms with different variables or different coefficients in front. And just looking over here, when I say coefficient, I just mean this term in front. And when I say variables, I mean just these letters. So for some of us who may need a little bit of a reminder, 3x just means I actually have 3 x's. I have no idea what the number is, but I know they have the exact same value. And for the second one, if I have a 4x squared, that means I have 4 sets of x squared. And again, I don't know what that x is, but I know I just have 4 sets of them. And that's kind of what a coefficient does. It just tells me how many of the variable I have. And so that's how we're going to get started for today. And we're going to just think about how do we represent this as in terms of multiplication. And one tactic I like to use with students is just think about just separating out the terms. So I know I have 3 times x. I'm just expanding it out. And 4 times x squared. I'm spreading it out. And I could even go a little bit further with this x squared, because I know that x squared just means I have x times x. X squared just means I have 2 sets of the same exponent. And what you're going to watch me do is I'm going to put things that are alike together. So I'm going to put whole numbers together because they belong together. And I'm going to put all the x's together. And that's really helpful because now I know something. I know that I can multiply these two numbers together. So I'm going to do that. 3 times 4, I know that makes 12. And I know that when I have the same number repeated in multiplication, I can use an exponent. In this case, I have 3 x's, so I can just write x to the third power. And that's how I would like to start when I talk about multiplying polynomials, is just breaking it up and decomposing it. And once this starts to make sense in your head, you can do it a lot faster and you won't have to use this strategy. And even in a case like example 2, when I have 3x times 5x to the y, 5xy, I can again just break it up. 3 times x times 5 times x times y. And I'm going to do the same strategy of just putting numbers together. And I'm going to want to put my x's next to each other because they're like terms. So I like doing that, where if they're closer together, it makes it easier for me in my mind to notice them. And again, I'm just multiplying my whole numbers to get 15. 2 x's there, make x the second power, and y. So I can still simplify out my term. So that's one idea that I want to just put across in terms of multiplying just 2 sets of terms together. So let's go into a more complicated one. Now we're actually going to use the model we talked about earlier last week, where we have an array, which is just, this is just my rectangle here. And what I'm going to do is I'm going to multiply 5n times 3x times 4n. And I saw this with a kid this week who was really struggling to figure out what happens in the box. So again, I'm going to just imagine this 5 times n times 3 times x in this box. Oops. Just draw that back. And 5 times n times 4 times n in the other box. And again, I want to put things that are alike next to each other, so numbers next to each other. And now I can start doing some math work that comes out, it almost seems intuitive. You can see it a little faster. So I know 5 times 3 is 15, and it's just an n, and it's just an x. 5 times 4 makes 20, and n times n, n to the second power. So this simplifies to 15nx plus 20 n to the second power. Why do I know it's a plus? Because up here there's a positive sign. So I can also note place that this is a positive. Matter of fact, let's just do that just for consistency's sake. So again, you can see how me just thinking about decomposing numbers can really help. If you're at the point where you don't need to decompose, you can just probably place those terms in there. 5n times 3x is 15nx, and just keep going. But if you're struggling to figure out what that multiplication looks like, just break down the numbers. So let's try with another one. It's a little bit more complex because now there's a negative sign involved. So let's put negative 8. Excuse that. Negative 8x and 2 and minus 5x here. And again, I'm just going to decompose because it's helpful. Negative 8 times x times 2. I'm not putting a negative with the x because then I know that negative times a negative will make a positive. So in order for it to say negative 8x, I'm just going to put the negative with the 8. And again, let's do the same thing with the other side. I have negative 5 times x. And now I can rewrite it combining my like terms. So I want numbers together and variables together if they're the same. Okay, and now I can just multiply out. Negative 8 times a positive 2 is negative 16x. Negative 8 times negative 5 is positive 40. And x to the second power. And so my answer being 16x plus 40x squared. Again, this is just me multiplying out, and I like being able to see my numbers. So just to kind of reiterate some of my success points here, I'm just using the array model to represent the problem, to make sure that I'm multiplying all the terms together I need to. I'm just really organizing my thoughts. I'm decomposing my terms, especially if they have a coefficient. So if I have a 3x, I'm separating the 3 from the x. And I'm expanding exponents. So if I have, let's say, an x squared, then I'm separating the x from the x. So I can see all of them. And then I'm just reordering terms. I'm placing things that are alike together, and that means numbers with numbers and variables grouped together. I want to put things that are alike next to each other because it just helps me see, especially with the variables. If I'm multiplying the same variable again and again, I'm going to use an exponent to represent that. And then finally at the end, I'm just multiplying my like terms. All right, so let's go up in our complexity just one more time just to make sure we really have this. And now I have multiple terms in this polynomial. So I have a 3x plus 4, a 2n, and a negative 4x. So again, you'll probably notice this is becoming second nature now. 3 times x times 2 times n, 4 times 2 times n, 3 times x times negative 4 times x. Oops, I don't know why my pen keeps doing that. 4 times negative 4 times x. Okay. Just put that in place again. And now I can just put things together that need to be together. 3 times 2 times x times n. So I know that that's going to be 6xn. And on the other one, 3 times a negative 4 times x times x. 3 times negative 4 is negative 12, and x to the second power because I have 2x is being multiplied. 4 times 2 is already next to each other, so that's 8 and just n. And 4 times negative 4 is already next to each other, so negative 16 times x. And now I'm just going to put all those things together. 6xn minus 12x to the second power plus 8n minus 16x. I'm going to just take one look to make sure that these terms they're all different. Notice none of them can be combined, none of them can be simplified. So I'm just double checking that I can't combine any more like terms. So I hope that made a lot of sense for today, and it hopefully just figured out for some kids who are really struggling with how to multiply terms to terms for the array model. I hope this is really helpful. I saw a lot of kids struggling with that in classrooms last week. And as always, I have videos on Tuesdays and Fridays, but if you'd like to see something for your classroom, by all means, you can drop a note in the comments, or you can, as always, just email me at sarah@mathminilessons.org, or you can follow my group on Facebook. I just started it for math mini lessons. And if you have any other questions, you can always put them into the comments. I love engaging with young people and with teachers and parents as well. I recognize this is pretty new for a lot of us, so I'm always open to having engagement and dialogue for topics just like this. I hope you had a great time watching for today, and subscribe to the page, and I will see you this Friday. Take care.